Hello everyone and welcome back to the channel. When we talk about asynchronous communication, message queue often come to mind. But there is a specific technology that takes distributed messaging queues to a whole new level, which is Apache Kafka. It's more than just a message queue, it's a distributed streaming platform, and understanding its unique use cases is crucial for any system design interview. Today, we are diving into the scenarios where Kafka truly shines, showcasing its power and versatility. And we're talking about message queue system. We don't talk about the famous Kafka, okay? But just, yeah, I put it as a joke. Okay, so let's just make a quick recap of Kafka. So before we jump into the use cases, to make a quick recap, what is Kafka? Kafka is a distributed fault-tolerant high-throughput system. It acts as a durable, persistent log of events. Messages aren't deleted after consumption. They stay for configurable period, allowing consumers to replay them. It guarantees ordering within a partition, which is a sequence of messages. It combines elements of traditional message queues with a publish-subscribe model, but with stronger guarantees and scalability. Okay, so let's start talk about Kafka use cases. The first thing we will talk about, which is real-time data pipeline. Let's first understand the problem. The problem is that moving massive volumes of data reliably and in real time between different systems. Traditional ETL or extract transform load process often involve patch jobs that introduce significant latency. When we use Kafka, Kafka excels as a central nervous system for real-time data. It's a high throughput, low latency, and durability make it ideal for continuously streaming data from various sources to multiple destinations. Okay, let's take an example to understand it clearly. So, collecting a vast amount of user logs from a website, like clicks, view, search, things like that, IoT sensor data from millions of devices, something like that, also, or maybe a real-time financial transactions. This data can be streamed into Kafka, then be consumed by warehouses for analytics, by search indexes like Elasticsearch, for example, or by any other microservice. Number two, microservice communication and event-driven architecture. And I would say this is big. So in microservices setup, tightly coupled services can lead to bottlenecks and lack of resilience. Direct point-to-point API calls often mean services wait for each other, and if one service fails, the others might follow. Okay? Kafka acts as a backbone for event-driven architecture. Services can publish event like order created, payment created, things like that to Kafka topics, and other services can asynchronously subscribe to these events. An order service publishes an order created, for example, an order created event for Kafka. After that, for example, the inventory service will consume this to reserve stock. After that, the notification service will consume it to send an email. After that, the payment service will consume it to initiate billing. Each service is decoupled and reacts to the event. The durable log means if a service goes down, it can read events from where it left off, or even replay past events if its state needs rebuilding. Number three, we have centralized logging and metrics aggregation. So let's try to understand the problem first. Collecting, aggregating, and analyzing logs and metrics from potential thousands of distributed servers and microservices reliably and at high volume is not easy at all. So Kafka shines here because Kafka's high throughput ingestion capabilities, durability, and robust partitioning make it perfect for acting as a central hub for all operational data. Multiple consumers can read the same data streams for different purposes. For example, All application logs, service metrics, and performance traces are streamed to Kafka topics. One consumer group might send them to Elasticsearch cluster for real-time searching. Another might send them to a long-term archival system, and yet another might feed into a real-time alerting system. Number 4, change data capture, CDC. Let's start to understand the problem. Propagating real-time data changes, inserts, updates, deletes, things like that to other systems like search indexes, caches, or analytics platform without relying on expensive polling or complex database triggers. So here, Kafka provides a reliable ordered stream for these database changes. Tools like Kafka Connect can integrate directly with database transaction logs and push every change as an event to Kafka. An example for that, maybe a user profile is updated in the main relational database. This is a change captured, sent to Kafka, and then consumed by search index services to keep the search index, or by caching services to invalidate update cached entry. Okay, lastly we have streaming processing, performing like real-time analytics transformations or aggregations on continuous streaming data. Kafka has a strength here, like because it provides the underlying persistent and ordered log that forms the backbone of various stream processing framework. Kafka Streams API and I guess it's Spark streaming or Spark streaming as well, all leverage Kafka as their primary data source and sink. Example for that, I guess, like real-time fraud detection, personalized recommendation, or maybe anomaly detection in sensor data. Okay, so when to recommend Kafka in an interview? So in a system design interview, recommend Kafka when you're dealing with high volumes of events or messages, like millions, billions, things like that. You need durability and replayability of messages. If message ordering is a critical thing in your system, if you're building a real-time data pipelines or event-driven architecture or event-driven microservices architecture, or you need a central data backbone for integrating many disparate systems, remember to acknowledge its operational complexity compared to simpler message queues. So, in conclusion, Apache Kafka is truly versatile and powerful platform for building event-driven, scalable, and resilient system. It's more than just a queue. It's a distributed comment log that enables a wide array of real-time use cases. Mastering these applications of Kafka is a key skill for any modern system designer. So that's it, and thanks for watching.